This is A21 Physics 4 and these are past paper question solutions on circular motion. So the first one is from Jun2004, module A21, module 4 it used to be called. Figure 3.1 is a cross-examination of the Earth showing your position in Northern Ireland's way 55 degrees north, 54 degrees are suggesting. As you're taking this exam, you're represented by the point S. Northern Ireland is at latitude 54 degrees north from the equator, as shown in figure 3.1, which is this one again. So there's our 54 degrees. Figure 3.2 is a plan view, so if we're standing in Northern Ireland, we're rotating around the North Pole. This circle joins all points of latitude 54 degrees north on the Earth's surface. 0 is the point on the Earth on the axis of the Earth's rotation at the centre of this circle of latitude. Again, you are represented by the point S. So there we are there. And obviously anybody who's down the equator, they're going to be a bit further out. So this line here, just to show you, because this will help later on in the question, that line there is represented by this line here. And that's the radius of our rotation around the axis. Calculate your angular speed due to the Earth's rotation. So your angular speed due to the Earth's rotation, well, we rotate once every 24 hours. So that's our time period, 24 hours. And we obviously need to change that into seconds. So omega is 2 pi over t. And that's equal to 2 pi divided by 24 hours by 3,600 seconds. And that gives you an answer of 7.3 by 10 to the minus 5 radian seconds to the minus 1. Calculate your linear speed due to the Earth's rotation. The radius of the Earth is 6.4 by 10 to the 6 metres. Now there's a wee bit of a trick in here because it's tempting to think that the distance that we need is 6.4 by 10 to the 6 metres. But 6.4 by 10 to the 6 metres is that distance there, and we need this distance here. So this is also 54 degrees, and therefore this line here is 6.4 by 10 to the power of 6 multiplied by, and then because it's beside it, it's a cos of 54 degrees. And that's the distance we're going to use in the radius for our linear speed. So V is equal to R omega. So our R value is 6.4 by 10 to the 6 times the cos of 54. And omega then is this value here, 7.3 by 10 to the minus 5. And that comes out to be 2.7 by 10 to the 2 ms to the minus 1. On figure 3.2, so back here again, draw an arrow showing the direction of your linear velocity when you're in the position shown. Label this arrow V. And so the position of your linear velocity, because we're rotating in this direction, linear velocity is always at a tangent, and therefore it's going to be up the way, and label it V. It then says calculate the magnitude of your acceleration. So A is equal to omega squared R, and omega we know is 7.3 by 10 to the minus 5. That's from part A, part 1. It's squared, and then your radius rotation is this value here. This one here, I'm just going to write that in up here. Our value of rotation is 3.76 by 10 to the 6. So I'm going to use that value down here, 3.76 by 10 to the 6. And so when you do that calculation, the answer comes out to be 2 by 10 to the minus 2 ms to the minus 2. On figure 3.2, draw an arrow showing the direction of your acceleration when you're in the position shown. Label this arrow A. So that's the last thing you have to do. Acceleration is always towards the centre of the circle, and therefore acceleration is in that direction, same direction as the direction of force.